So in this data resource, it's about people with pancreatitis and people without, and it tells you in the text at the top that pancreatitis can be sort of diagnosed by having a high concentration of amylase in the blood, so the pancreatic duct is blocked. The data in this table here also reflects that. You can see that there is a higher concentration of amylase in the blood of people with a blocked pancreatic duct than there is in healthy people. But what happens to the trend if you compared the two? Is it just the fact that these have got higher, or are there other trends as well that's in place? So if you're going to describe or compare the two graphs, a good way that I think of doing that is to do a sketch graph. So just anywhere around the outside or underneath you've got a bit of space that's not in part of the answer. Do a sketch graph. So in this case you can see as time goes on, the people with blocked pancreatic ducts, there's a rise, there's a peak at 24 hours, and then it drops. So you can see here, rise, peak, drops. Whereas in the healthy people, the sketch graph, again, as time goes on, it goes down, and it comes back up again. So it goes down, and it comes back up again. Another thing that you can spot as well, so the trend is different, so this goes up and down, that goes down and up. But another thing you can spot is that these numbers are always lower than these numbers, so healthy people always have a lower concentration of amylase. So that's one way you could diagnose it over a 48-hour period. But another way that you could diagnose it is this starts higher and ends lower. It starts at 1,800 and ends at 1,400, whereas the healthy person starts and ends over 48 hours at the same concentration of amylase. So a bit of exam technique: if you're asked to describe data and all you've been given is a table, do some sketch graphs, and I think it helps to describe what you're looking at. So there's more to go on from this, from the data that we've got here. So this is about testing two types of washing powder. Type A has got enzyme, type B is without enzyme. So we want a direct comparison between the two. We want to see if the washing powder with enzyme removes more of a stain than without enzyme. So we've got important units over here. So we've got percentage of stain removed. Again, like we've seen before, this allows comparison because the stains could be different sizes to start off with. So you couldn't just say what's the final size of the stain. So if you look at these two, we've got two rough sketches of a stain that you might find on some clothes over here. So if you've got a small stain to start off with, you might have a smaller end, but this one might have removed more of a stain in comparison. So because the size of the stains differs, then you have to have some sort of units that allows comparison that takes that into account. So all the data we've got provided, get the question, evaluate, so that means we need agree points and disagree points. Evaluate, does enzyme washing powder, is it better at removing stains? So first of all, let's see what the agree points would be. In every single one, so I've done a little red arrow to represent on each of these bars, every single time less stain is removed without enzyme, or more stain is removed with enzyme in every single type of stain. So that's an agree point. There are some where it's particularly effective. So it's got the highest removal of chocolate milkshake. And you've also got quite a large difference here as well with chocolate milkshake. And you've got quite a large difference with salad dressing. So that's another agree point. So for chocolate milkshake, very effective. But as is often the case, there's a lot more points that we can say. Can't really conclusively say that the enzyme washing powder is better. So first of all, we look at both the raspberries. We've got raspberry smoothie and raspberry sorbet. There's very little difference here. So not much of a drop at all, or not much of a difference in the percentage. There's no standard deviation bars used at all. So I've drawn on some here for what you'd want to see, to be able to see if there's a significant difference or not. So if you had them, you could see if there's no overlap, you'd have a significant difference. If there was overlap, you wouldn't have a significant difference. There's no standard deviation bars. You can't really compare the two bars. Even better would be if we had a statistical test. So if you've got a tick list that you're going through when you're doing an evaluate question, always ask yourself, has a statistical test been done? Can you see to the level of probability that the difference in this case was due to chance? and no we can't. There's no information about the number of repeats, so we don't know if the results are, the mean is reliable or not. We've got no idea of that at all. And also, there's only 5 stains being tested. There's all sorts of other stains that you might want to get out of clothes, and before you want to make that decision about which sort of washing powder you want to make. So, for example, what effect does this have on grass stains? So, because we've not got very many different stains, it might not be representative. Representative is an important word of all stains.